All right. Let me know if the quality is not good. I think I have it in focus pretty well. Yesterday, which was Monday, we did a quiz review thing on 1 through 4. So today we're going to do 5 through 10. Lessons 1-1 through 1-4, and today we're doing 1-5 through 1-10, and that should somewhat aqueductly prepare us for the test on Thursday. For exercise 1 and 2, lines P and Q intersect to form adjacent angles 1 and 2. So here's a line, you can barely see. Here's a line P, here's a line Q. They intersect to form adjacent angles 1 and 2. According to question 1, if the measure of angle 1 is 7x plus 6, so I'm not going to draw it out here because 2 changes the rules a little bit. If the measure of angle 1 is 7x plus 6, and the measure of angle 2 is 8x minus 6. Find the value of x so that P is perpendicular to Q. In order for P to be perpendicular to Q, they have to both measure of angle 1 and the measure of angle 2 have to both be 90 degrees. So there's 2 ways that I could set this up. I could either set these guys equal to each other, or I can set one of them equal to 90. So it really doesn't matter. I'll just set one of them equal to 90. I'll just set that equal to 90. 7x plus 6 equals 90. Again, if they're perpendicular, then they form 90-degree angles. So this picture is bad. If they were perpendicular, then the picture would look like that, where you have 90-degree angles. And so angle of 1 and angle 2 would be 90, like so. And you could either say that the measure of angle 1 is 90, or the measure of angle 2 is 90, or the measure 90, or the measure of angle 1 equals the measure of angle 2. But what I'm doing right now is I'm purposely stalling so that you guys can figure out x before I do, and then post it in the chat. I'm going to subtract 6 from both sides. 7x equals 84. Divide both sides by 7, and someone has it. It's Athena, and she's right. X equals 12. Is that what I was supposed to do? Whoop! Is that what I was supposed to do? Find the value of x. Yep. X is 12. Okay. Now the rules have changed for problem 2. Problem 2 refers to a completely different picture. If the measure of angle 1 is equal to 4x minus 3, and the measure of angle 2 is equal to 3x plus 8, find the measure of find the value of x so that 1 is supplementary to 2. 1 is supplementary to 2 means that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So what I set up, according to what I have up here, is the measure of angle 1 is 4x minus 3, plus the measure of angle 2 is 3x plus 8. That equals 180. I'll give you a 20-second head start. Now, those of you who are able to do math and listen at the same time, this problem, you're not allowed to be cute with the rules like this one could, because it's just straightforward. It's got to be supplementary, which means 2 angles that add up to 180. Once you get x, put it in the chat. Okay. So we have an answer up there already. Let's see if that answer is correct. I'm going to combine like terms, 7x. I'm going to combine like terms, plus 5 equals 180. Subtract 5, cross u out, 7x. Just making sure you guys can see what I'm doing. 7x equals 175. Divide by 7, divide by 7. And according to our good friend Athena and Camilla, x will equal 25. And I wholeheartedly agree. So all I had to do for problem 2 was find the value of x. I don't have to plug anything back in like we have done several times before. X is going to equal 25. Boom! Booyah! Booyah! If x is 5, find the perimeter of a rectangle whose length is 6x minus 4 and whose width is 3x plus 2. All right, well, let's draw a rectangle. That's the best rectangle ever. Let me see, 6x minus 4, width is 3x plus 2. Thank you, Santi. Of course, I don't know if my rectangle is accurate at all according to my answer, but that doesn't really matter. All I have to do is it tells me that x is 5. So if x is 5, then I get 6 times, and by the way, 6 times 5 is 30. 30 minus 4 is 26. And if so, this side measures out to 26. And again, if x is 5, then 3x plus 2 is going to be, 3x plus 2 is going to be 3 times 5 plus 2, which is 17. So this side is 17. So I'm going to give you a 20-second head start to see if you can write out the perimeter in the chat. I already have somebody with an answer. So let's see if they are right. Remember, perimeter is you just add up all the sides. So there's 2 ways that you could do this. You could either do 26 plus 17 plus invisible 26 plus invisible 17, or you could do 2 times 26 plus 2 times 17. And that, what will that be? 52 plus 34 equals 86, which is what Athena and Santi said. What are we talking about here? I'm looking for a unit. I don't see any, so no inches, no centimeters. So 86. Uh-oh. So 86. Not. Thank you. Thanks, buddy. 86. That is all. The perimeter of a convex polygon. Now, remember, there's 2 types of. Thank you for not cursing, Camilla. What was I going to say? The perimeter of a convex polygon is 15 feet. The perimeter of a convex polygon is 15 feet. What is the effect on its perimeter if each side is doubled in length? Okay, so let's just. Convex and concave, yes, that's the 2 types. A convex polygon just looks like this. So that's just an example of one. If all of these add up, if the perimeter adds up to 15, and I double the side length, all it's going to do is double the perimeter. I'm not a fan of that. I'm not a fan of that problem. Welcome back, Lily. Ah, good. That pentagon has 5. Did I call it a pentagon? Sorry, Santi. Listen, I'm edgy, bro. I'm edgy. I'm not some rando math teacher that just does things normally. I'm edgy. And you see what I did there? I didn't even realize that I punned so hard. Punned so hard, all my friends want to find me. For a triangle ABC with vertices A... Oh, wait a minute. I don't have a... Do I have a coordinate plane worksheet? Yes, I do. Look at that. Do I have the points? Yes, I do. So I'm using scrap paper for once in my life, and it's a good thing that I did because it's talking about ABC with those vertices. Find the coordinates of the vertices of the image after reflection over the y-axis. So let's actually graph it out. A is -2, 3, put a dot A. And by the way I got these graphs is I just Google image search blank coordinate plane, you know, and I printed it out. If you don't have a printer, that's no big deal. You just draw your own coordinate plane, and you should be able to use common sense to kind of figure out the rest. But anyway, A is -2, 3. B is 3, 1. And C is 0, -4. So that, ladles and jelly spoons, is my triangle. What I'm supposed to do is I'm supposed to reflect this in the y-axis. There's my y-axis. So this guy is going to literally reflect on top of itself. It's going to reflect on top of itself. I just want to make sure you guys can see. Is the quality of, or the focus okay here? Seems pretty good. It's never going to be perfect. Boy, I sound like me when I'm comparing myself to my dad, right, guys? Right? Mm-hmm. Y is my mirror. So I'm going to actually draw a line on the y-axis to be that mirror. If A is on the left side of the mirror and I mirror it over there, A is 1, 2 spaces away from the mirror, which means A prime is going to be 1, 2 spaces away from the mirror. B is on the right side of the mirror. So 1, 2, 3 units away, 1, 2, 3 units away, put a dot, and that's B prime. C is touching the mirror, which means C prime is also touching the mirror, and there's my picture. What a cool looking picture, very 3D-like. Looks like a dart being thrown on the ground. Find the coordinates of the vertices of the image. All right, well, A prime is now over here. A prime is 2, 3, so A prime is 2, 3. B prime is over here now, which is left 3, up 1, so B prime is left 3, up 1. And C didn't change, so C is 0, -4. Cool, gang. Dope. Dope job, gang. Hey, gang. Hey, ghouls. Hey, gang. Dope. Trying to use slang. Oh, well, how did I do? What do you think? That's lit or dope? Or is that hype? Thanks, Santi. It is lit. Lit like a campfire. Thanks, Athena. Anybody else want to throw a compliment in the chat? I'll accept it. All right. The volume of a pyramid is 27 cubic centimeters and its height is 8 centimeters. Find the area of the base of the pyramid. I don't know the formula for the volume of a pyramid. So let's look it up. Volume of a pyramid formula. All right. So the volume of the pyramid formula is V equals length times width times height divided by 3. That's super convenient. But that's probably not the equation that we're going to want to use. What is the area of the base of the pyramid? Actually, you know what? Let's go with it. Let's just go with it. Oh, all right. Too late. Length, width, height divided by 3. Okay? The volume is 27 cubic centimeters. So I'm going to replace V with 27. Length and width is, so if I have a volume of a pyramid, so there's my pyramid. I don't know what type of pyramid it is, but there's a pyramid. I know that the height up to down is, what does it tell me? It's 6. So length times width times 6 over 3. Now, let's not go insane and be like, what do I do first? What do I do first? It really doesn't matter. First off, 6 divided by 3 is 2. So I have 27 equals LW times 2. Divide both sides by 2, and you get 13 and a half. 13 and a half is length times width. Now, what do they want us to find? The area of the base. Well, remember, the base means the entire bottom. And how do you find the area of a base? Multiply length times width. So length times width is base. So the equation that the book probably gave us, if I were to actually use the book, and you could, remember, you just go to your bookmarks and you go to the red icon that has the book, and I can care less if you use the book while you take the test. The equation it probably has for you is either BH over 3, or maybe it gave it to you as V equals 1/3 BH. Doesn't really matter. You're going to get that. And so my area is 13.5 centimeters cubed. Now, why centimeters cubed and not centimeters? Because it's looking for the area of the base. And so an area is measured in centimeters squared. Volume is measured in whatever cubed. Area is measured in whatever squared. And length or height or width is just centimeters. A hexahedron has 6 identical faces. What is the shape of each face? Any idea? This is one of the ones that we saw in the, this is one of the ones that we had in our notes. It was, we forget what video it is. I forget, it was the name of the lesson called polyhedrons or polyhedra. No one's really saying anything. Well, remember. Yes, Santa, yes. Very good. Hexahedron has 6 identical faces, which means all the sides are exactly the same. So think logically, there's only one shape that has 6 sides that are exactly the same. Think of maybe something that you would roll when you were playing games, when you were bored.
A dice, but like a cube?
Yes, so all the sides are going to be what? All the sides are going to be what? All the sides are going to be what?
Equal?
Yep. But what specific shape?
The faces? Like the squares?
Yeah, squares, that's it. Very bizarre question. Good, Lily. A very bizarre question. I mean, it basically, I'm not going to lie. If you're not sure what a hexahedron is, Siri, what's a hexahedron? So, you know, hexahedron is not a word that you and I, when we go out on the streets, we're going to use a whole lot. So we just call it cube. And if it has 6 identical faces, then that hexahedron has to have the same face. I mean, technically, a hexahedron could be, if it doesn't have 6 identical faces, it could be a rectangular prism. But since all the faces are identical, they're all going to be square because it's a cube. Ugh. Draw the front view of the drawing. Okay? This is what I'm absolutely awful at. But if I were to stand right here, if I were looking right here, okay, here I am, and I'm looking at that building over there, what am I going to see? Well, what I'm going to see is, like, I have like 2 towers behind 2 shorter towers. So the front 2 towers are going to look like this. I may have not given myself enough space here. The front 2 towers are going to look like this. Are you with me? Now, directly behind this tower on the left is a tower of 4 squares. So behind that is going to be another square, oh my gosh, and another square. Behind the tower on the right, you have a tower of 5, so I have another square and another square. So technically, the picture that I draw is going to be, sorry guys, the picture that I draw is going to be, meh. Now, fortunately, you will never have to do anything like that on a computer test. It's very possible that you see one where it's multiple choice and it asks you for the front view. But, you know, the good Lord didn't create me to be an artist. Unless the art in which I excel at is math. In which case, he did create me to be an artist. We're like fartist, am I right, Santi? Come on, bro. Ha ha ha! Yes! Problem 4. Find the absolute error of a length of string that measures 9.5 inches. What we learned in that last section, is 3 things. We learned absolute error, we learned relative error, and we learned significant digits. So again, these are all videos that you can find in that pen and paper format that, you know, I posted on the YouTubes. But absolute error says you just take your smallest unit and take half of that. So the smallest unit is going to be a number in the tenths space. Tenths. So what I'm doing is I'm taking half of that. It's half of a tenth. Now I'm writing it out in fraction form because I just want you to visualize it that way. But half of a tenth is given to us as 0.1. So, or think of it this way, 0.1 would be like 10 cents. So half of 10 cents would be 5 cents, not 0.5, but 0.05. So the absolute error is half of the smallest unit. So this is one of those things where if you see a problem like this on the test, you may have to run to YouTube and type out absolute error and remind yourselves how to do that problem, because absolute error is just not one of those things that we're going to run into in the real world, and we really can't use common sense to figure out. You know, some of these problems, you know, like problem 2 up here where it asks for a hexahedron. Again, if God forbid you don't remember how to do hexahedron, all I did was ask Siri to give one for me, and it gave me the answer almost immediately. You know, most of you could have probably done 3 before we even learned anything this year. 4, on the other hand, absolute error is something I never heard of until I started teaching literally this class. I never did absolute error in high school. I never did it in college, even though I have a master's degree in math. And this is the first time that I'm seeing it. Maybe I did do it before way back in the day, but I'm so old that I don't remember. I don't even remember what I had for breakfast, right, gang? Ha ha ha. Paul, thank you for correcting Sandy's lack of punctuation on the last A. I do see what you did there, and your effort is appreciated. Anyway, absolute error is half of the smallest unit. The smallest unit is a number in the tenths spot. So half of a tenth is 0.05. So my absolute error is 0.05. Now, if it were to ask me for the actual measurements, which it's not doing, but if it were to ask me for the actual measurements, what I'd do is I'd take 0.05 away from that number. So 0.05 taken away from that would be 7.45, and 0.45 or 0.05 added to that would be 7.55. And we saw that a bunch of times in that class that we did. The trick behind significant digits, and again, that was a video too that we did. The trick behind significant digits is a significant digit is any non-zero number, but you include the zeros in between. So that's a non-zero number, that's a non-zero number, that's a non-zero number, and you include any numbers in between, or any zeros in between, and since 0 is in between, we have 4. And the only time that you would include a 0 at the end is if you would have something like 4.30. That extra 0 there at the end of a decimal is just being precise. So we would say 1, 2, 3 significant digits. But again, all of that can be seen in videos.